Hey there. Long time no see. last uh, last video I think I put out was for that triplet, and I think it was back in December, so it's been a hot minute. But for anyone else who might have watched that and seeing this, nice to see you again. I just wanted to give a bit of an update on some of the project I've been working on on the interim there before school had started back up. And if you excuse me, I just got the weather's changing, so I got some phlegm. But the project I wanted to share, I wanted to make this quick because I don't want to have to splice two different videos together for something like this. I think it's interesting enough as is to stand alone. So, but the project that I had been working on before school started was this guy. It's an EEPROM programmer, actually. Let me put that in better view. I'm sorry. On YouTube, there's a man by the name of Ben Eater, and he does a video specifically about an EEPROM programmer. Goes into the details behind it, and also builds one. And walks through what would be the Arduino code that would effectively handle all the communications to your shift registers and then to your EEPROM. The reason why I wanted to share this specifically was because there is some differences between what he was doing, at least hardware-wise, and what I've been doing. And so I thought it warranted enough to be able to talk about it and maybe be able to show that, workaround, doable. So first things first, obviously pretty to the point. It's just a normal Arduino Uno, nothing fancy about it. Otherwise the components, we got some 74 HC595s right there. There you go. And right here too. I'll talk about this one. It's different than what Ben had done in his video. And now this guy right here, this EEPROM, it is a M5L 27128K. I don't know how to say that designation. So that's the best I'm going to give it. And this is one of the variations, the EEPROM, to what Ben had been doing. And then this shift register here was a variation, though I decided to abandon it and just go with Ben's design in his video that he was doing. Specifically though, to show you, one second. Here's that those 74s. So I mean, it's pretty standard, right? It's generic diagram for you, and you can find that anywhere online. And now here's that M5L. So, oh, I'm sorry. I am being very goofy with my movement. So it's a little under 16,500 word by 8-bit. So it's got some size to it, I guess. Certainly is for a low-level project of what I'm trying to work on right now. I'm trying to make it as generic of an EEPROM as you can get. I'm honestly just trying to put, I think, hello world in their respective bits, starting from, I think, address 0. Though that could be, that shouldn't be an issue. So you can see there's a single 5-volt for supplying for the read-only. And now it comes with a fast programming algorithm right there. That one's a bit trickier because I'll explain. Now what makes mine different than Ben's is that I have, I think it was 2, maybe 3, 2 or 3 extra address pins. So I have a total of 14. I think his might have either 11 or 12. And then of course also his only has the VCC here for the 5 volt, whereas I have another one, a VPP, that can take either 5 or 21 volts. 21 volts comes into the programming bit. And so that's where things get tricky. The fast programming if you're to supply to the VCC 6 volts and then to the VPP 21 volts, then, I mean, it's fast programming. It's kind of self-explanatory. My issue is that, of course, I'm, just powering it from my computer, and so I don't have, it's not going to output 6 volts. So, and I don't want to have to deal with all the hassle of figuring out something. So I was going with the conventional programming algorithm here. So it's just a supply 21 volts to that VPP, and then a low onto the chip enable, and then from there you designate an address on the lines, your data, and then you give a pulse between 45 and 55 milliseconds. So that's the quote-unquote overview for that chip here. It's a fairly old one I got from one of my classes a good few semesters ago, but it's only till recently that understanding a little bit better, at least in principle, and realized where I was going wrong once upon a time when I once tried this. So I wanted to get into what differences I made, things I tried to do. So besides these address lines here, there being a few more, all I had to do was give a few more jumper cables, right? Nothing crazy. The way that Ben has his tutorial teaching whatever is set up is, so we get these lines here. We got the data, shift, and latch lines, and data goes into the first shift register. I'm so bad. First shift register right here, and then the overflow of this register becomes the input of this one. Yeah, there you go, that one. So that way then you can be able to use the entire line here. Now, let's see. The clocks are also tied, so they act in parallel, though for the data out it is serial. And of course all these handle the address designation, so I think when I was trying it, I was just doing 0, right? Nothing crazy, and that's also what Ben was doing too. Now this is what he had in his video for handling the data. It not only would handle the data in for the EEPROM to program, this would also handle the data out from the EEPROM to be able to read, to verify that you've written data correctly and successfully. Now, the variation that I tried to do, because I wanted to try and save as many of these pins here as possible, just in case, try and minimize it, maximize efficiency, is I wanted to stage my data like here for these guys. I wanted to stage it out of this guy, and so I would only then have 3 lines here: output, latch, and shift clock. And then from here, it gets printed out. And of course, as you might imagine, the issue is that I cannot read from it. I'd have to disconnect and go to all this work to rewire these and change the Arduino code in order to, once I'm done writing, read. And it became a bit of a hassle, but in theory, certainly, if I knew that it was working for sure, this would be certainly a smart idea. Again, save myself if I need to then use these lines here for something else, then I'd be able to. But I wasn't. Not sure quite why. Again, I was busy with schooling and a few other things, so I wasn't able to devote as much time as I'd like. But that's my update here. Just wanted to kind of give an overview of this project. Again, show that something like this can be done off the bat. I I have it just right off here to the side, but for that power supply, it's just a doctor meter. So it's like, I think like $50. It's not too bad. Supplies what I need for the job. And otherwise, yeah, there's a few other projects that I am working on for schooling, though it kind of does coincide. I get to do it for school, but it's also been a personal project I've been interested in for a little bit, wanting to try and step forward with. So hopefully here come July, I'll have something because I need it for my schooling, and I'll be able to show you guys that project when the time comes. I won't give any spoilers. It's nothing crazy, but I think it's going to be fun and cool. Certainly we'll learn a lot. So thanks for watching all the way through if you did. And probably could get better at this, but leave a like on the video, would appreciate it. Honestly, I'm doing these anyways just because I really want to. I'm trying to work on my speaking and, I guess, in a way, presentation, but kind of blogging, I guess you could say, memories of a sort. Anywho, catch you guys later. Have a great day, and again, thanks for watching.